Howdy. Welcome to the Lone Star State, the state where chips and salsa are the state snack, and most importantly, the state of Enchanted Rock. According to a pamphlet I found in Fredericksburg, about 300,000 people come here each year to hike, climb, or take yoga photos at the top. But most things in Texas don't stick out of the ground like this. So, what is it? And better yet, how did it get here? But if we're going to fully unpack this, we have to go back. All the way back to 1400 million years ago. To a time where primitive tectonic plates came together to form Rodinia, a supercontinent. Yeah, there was one before Pangea. Some continents started approaching present-day Texas, and underneath the sea separating the continents, a subduction zone formed. The subducting plate started to sweat, in a way, and it released fluids that triggered melting. This melted rock started to rise to the surface, forming a volcanic arc. But then the southern continent kept moving, and eventually collided with its friend, the volcanic arc. A new subduction zone formed near the present-day Lanao region, forming another volcanic arc, but this time it was on the continental margin. The continents kept on trucking towards each other and eventually fused together, leading to uplift across the entire Lanao region, kind of like what's happening in the Himalayas right now. As collision proceeded, a round of batholiths began to crystallize under the surface, and they're shown here as plutons like Enchanted Rock. But wait, what triggered these plutons to form like that? We'll need another claymation video to explain what was going on below the surface. As the southern continent crashed into modern-day Texas, it thrusted the island arc, shown in black, onto the eroded basin sediments, in yellow, onto the continent. The crust thickened to about 90 kilometers with temperatures reaching 750 degrees Celsius, leading to massive deformation and regional metamorphism. Those metamorphosed basin sediments can be found today in a nearby road cut. You can even see where the rocks have been folded during the deformation caused by collision. These are graphitic phyllites with interlayers of quartz-rich phyllites. There are also some thin quartz veins that parallel the foliation and are butinaged. But back to the story. At some point, the subducting slab broke off, thrusting some asthenosphere past the melt zone. Melted rock began to rise up into the crust, with some larger bodies, or batholiths, rising as well. Enchanted Rock landed about 8 to 10 kilometers below the crust, and the overlying rock had to be eroded away for it to be seen today. So, what is this mountain of rock made of? Well, it's mainly composed of potassium feldspar, the pink minerals, plagioclase feldspar, the whiter minerals, quartz, in gray, and biotite, the flaky black mineral. These are the set of minerals that we find here because they specifically crystallize later in the process. So minerals like olivine and pyroxene crystallize first and get left behind when the pluton is rising. The ones that are left are the ones shown here. You can also spot flow foliation at Enchanted Rock. This happens when crystallized grains of potassium feldspar align with the flow of the magma before the magma completely crystallizes. When the magma cooled, it contracted and formed fractures. The remaining magma that hadn't totally cooled was injected into those fractures, and depending on the rate of cooling and the amount of fluids in the magma, you can get different crystal sizes. This is an apelite dike that is assumed to have cooled relatively fast due to its tinier crystal size. Enchanted Rock is also what we call an exfoliation dome. It's kind of exactly like an onion. The outer layers are thinner than the inner layers, and the sheets also tend to be thinner at the top compared to the base where you have larger isolated boulders. So, if you get a chance, go to this gem of a location. This region has had a complex geologic history and it definitely deserves a visit.